Hello guys, I'm Maluko Shao. Welcome to my tutorial on how to create and automate binomial distribution simulation graph model using Excel package. Okay guys, I just need to acquaint you with some few things now before I get started with this tutorial class. Let me quickly explain to you what binomial distribution is all about. Okay, the binomial distribution arises from a repeated random experiment which has two possible outcomes. That is that an event will occur or that an event will not occur. So meaning that in binomial distribution model or distribution probability, we have two possibility, probability of success and probability of failure. I don't know. Is this how to spell success, guys? I'm sorry about that, huh? Success. Okay, just take that, guys. It's about using Excel package to model a binomial distribution graph. Okay, so that what I want to learn. So forget this. But I just want you to know this. Okay. I don't know if you are a college student, then you should be well acquainted with this. Probability. Okay. Our statistics. Okay, now guys, I need to call your attention to something. The parameters of binomial distribution are n and p. Okay, n, that is the total sample space or the total population or the total number of um, events you are taking into consideration, and p is probability of success. Okay, and then automatically q will be probability of failure. Okay, let me just take one sample problem. Let me just give you an illustration, then we get started with it. Let's say, for example, the probability of a boxer becoming a world champion while under 30 years of age is 2 out of 3. So the probability of success in that case will be 2 over 3. Okay, so if probability of success is 2 over 3, since the probability um, of a certain event is 1, so then failure will be 1 minus success. So you can take it as vice versa. Okay, if probability of failure is 2 over 3, then success will be 1 minus that. Or if you talk about in percentage, I don't know what 2 over 3 will be in terms of percentage. Let me just quickly make use of my calculator now. 2 out of 3 is what? 2 out of 3 is that is 0.66. Okay, so that's 0.67, approximately 0.67%. So if p is 0.67%, okay, or let's say 0.60, I don't want to use this report. If it's 0.60, that is 60%. Okay, so then failure will be 0.4 and that will be 40%. The probability of success is 50 and probability of failure will be 50% too. If in terms of percentage you can use 50%, but in decimal is 0.5 and in fraction it is 1 over 2, and that will be an evil chance. Okay, for ks3 ks2 students, evil chance. And what probability that is going to rain today is 1 out of 2. So it's either probably it rains or not. So that's probability. So you know what the parameters are going to use are np and q, and from np and q then I'll be able to create this my mathematical model for binomial distribution. Okay, so let's see how it works. Now what I just want to call your attention to is this, guys. Let me just quickly say this before I check out this graph work. Okay, now you can vary the value of p to generate new q. Okay, then also to generate a new probability density function. This is probability density function of binomial distribution. Okay, and also to automate the graph. Okay, so it's like automation is going to change the graph based on the changes in probability density function. Okay, so now what I'm going to do now is to alter. Now for now I will just want to work with 8 samples. So my sample space is 8, or let's say population. Okay, sample space 8. Okay, so let's say I'm considering just 8 different trial. Okay, so now, or let's say probability of if you toss a coin, probability of you either get head or tail. So let's say probability of obtaining head is 0.6, then tail will be 0.4, something like that. Okay, now let's alter this now. Let's have evil chance. If this one to be 0.5, then my failure should be automatically 0.5. Then it's going to generate new probability density function. Then it will also reflect in the graph and in the table automatically. So that's simulation. It's a model. Okay, so it's like can I call it a machine learning or kind of something? So it's going to automate itself. Okay, so it's a unsupervised machine learning. Let's just say this is unsupervised machine learning simulation graph, something like that. So because it's going to create a new graph based on changes made to this. Also for 0.5 now, just click enter key on your keyboard and you see small changes because let's just take it something like 0.1, 0.1. So let's see the effect of that. So you can see now it's skewed to what? Skewed to the statistical students or probably professors and students. My KS2 will probably understand this. So this is skewed to this skewed to the right or left, and because it goes up or probably it comes down, so this is skewed to the left. Okay, so this is falling, so it's this is a negative graph, so it falls or like a backslash, so it's negative, so it's skewed to the left. Okay, now if I make my success to be more, then the chances for you to pass will be more, so that will skew to the right. So let me make this one 0.8. The probability of success is 0.8, that is you have 80% chances of succeeding, then that's 0.2%, sorry, 20% of failing. Okay, so that will skew to the right. So let me press enter key now. You see now skew to the right. Now if I want to make it 50-50, that is a probability for you to pass or fail is 0.5. That is you have 50% of passing or failing, so that will be like a form of symmetrical distribution. So see symmetry at the center here. So because it is even, if I use my print screen now, you see that it's evil chance, and this is evil chance because you have something like this. It has a bell shape. Okay, but if I make my success to be more, then you have high tendency to succeed. Let me change that again so that you see how the graph work. Let's say that your probability of succeeding is 0.8, or let's say 0.7. That is 70%. That is B. Let's go for A, guys. 0.8. If I click enter key now, so you now see now, so that's that you have a very high tendency to succeed, and that is a which type of graph is that? And if you look at it now, this one, you increase it, it's increasing. Oh, it's increasing. Your chance of success is very, so it's increasing. Okay, so that's, you say scale to the right. Okay, and that is a positive graph too, and that is forward slash in if you are doing programming. Okay, so but if I want to do something like this now, if I want to, I don't want that the probability of succeeding is very low. That's something like 0.2. Then let me just use 0.3 this time around. That is 30%. Then you have 70% of not succeeding, so that will skew to the left. And say that skew to the left. Now what does it mean to, what is the meaning of that skew to the left? So you see that is like it's decreasing. So this is decreasing. It's a decreasing function, something like that. It's decreasing. Okay, so and that is a negative graph, something like that, for you to understand. And that is backslash in programming. Okay, backslash n. So for example, you want to create a space. Okay, so that's enough, guys. Now guys, do you care to create a wonderful binomial distribution model like this using Excel package? Then let me teach you how to do this. I've taken a lot of time explaining how this graph work. Okay, so let me teach you how to do this. Let me just create a new, I can close this and create a new. So this is a new blank workbook. Okay, and I can close that page. Let me see, let me just close that, so I don't want to have access to it. Okay, so it's not available again, right? um Let me just close it so that, so Haluko is cheating, is looking at how to do it. Okay guys, let's get started with, wow, binomial distribution simulation graph. Okay, so now don't forget, what are the parameters needed to create a binomial distribution model using Excel graph? The first parameter you need is your sample space. So the total number of experiments you want to take into consideration. Okay, maybe you toss a coin 10 times or 50 times. Okay, so let's say you want to toss n times. Okay, so number of sample space. Or you get a student and you want to give them injection to see the effect. Or like we are in times of COVID now, you want to see, I think based on German American COVID, what do you call it, guy? I'm not a medical guy. Okay, coding, soft stuff. I'm not coding, I mean, what do you call it? You want to give injection to take to have to be to have resistance against COVID. Okay, I think they said it is 95%. So it is 95% effective. Okay, so that will be probably of success will be 0.95 in that case. Then let's say they gather how many patients to test the whatever they produce. Okay, so now I want to take 8 sample space. So let's say n is 8. So now since probability of success is P, so that is success. Okay, success. Okay, so now probability of success now, let's take that to be, okay, let's just work with the anti, I don't know what they call it, anti COVID stuff, okay, serum, whatever. So let it be 0.5% effective, so that will be 0.95. So that's 95% effective. So if it is 95% effective, then failure will be what? Probability of failure, let's take that one to be Q, because I need that parameter based on, that's the normal, that's what we use as so failure. So mean that it will not be effective will be 0.25, that is 25%. That's 5% not effective, that's 0.05. So how do we get that? Don't forget in Excel you use equal sign to create your function, and probability that an event is certain is 1. So now, so that will be 1 minus probability of success, so this, so that's that. So if I press enter key, that should give me 0.05. Okay, correct. So if it is 95% effective, then that will be 5% chances of not being effective, something like that. English guy, okay. So now the first three parameters we use in binomial distribution are n, p, q, where n is the number of sample space, p is success, and q is failure. Now so this is r. So you want to select r. If you have like, if I gather 10 patients all together, then I want to take like 2, test 2 out of 10, something like that. So r. Okay, so now so my r now is since I have 8 sample space now, so I have 0, 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 sample space. I can increase on this later, don't worry guys. Then now we the probability density function. Let me quickly write that down, okay, for statistics students. You know what I'm talking about, okay. A probability density function for a binomial distribution is given by n combination r, okay, and p r, okay, q, n minus r. You already know what each parameter stands for. N stands for total sample space. So r is the number you want to consider in n trial, and c is combination. Is your calculator, you can see that combination is a function. P is probability of success, q is probability of failure, and that's what I want to write here. So I need r, n, p, q, then I'm going to complete this probability density function, okay. So let's do that. So that's r. So then if I have my r, so the first function I'm going to describe is n combination r, okay. So n combination r. Okay, so lowercase, and if you look at your calculator, this should be up superscript. Okay, so format cell, be fast guy. Okay, so I need superscript. Okay, just wasting time, I don't know. Don't waste, I need to upload this video guys. Guys, okay, thank you. So superscript, okay, so that should be for the n. Then I want this r to be a subscript, so format cell subscript. Okay, so and if you go you just check your calculator, you see something like n combination r, okay, it's a function. Then also I'm going to need pr, because based on what I wrote, why so I need pr qn minus r. So let me just write that and that is p subscript r. Let me just use uppercase p subscript r, then q then subscript n minus r. Okay, so I can make it now. So pr, so that p raised power r, that's a subscript guys, raised power or index. So subscript r. Then I need qn also raised power, is a power or index, so it's also a subscript. Okay, then I'm now going to combine this in order to get my binomial distribution density function. So I need n combination rp and qn minus r all together. I don't know whether I should copy, or I don't know if it's going to work for me, I don't know, but let me just write n combination r p r q n minus r. So this will be a superscript. So go to format cell and take your superscript, and this also will be superscript. So format cell and click on superscript here. Guys, what I did there is just to right click, right click, highlight n minus r, then I right click and go to format cell, and you can take your superscript or subscript accordingly. So don't forget, this is the formula I wrote then when I use my this similar to what I did here. N combination r PR qn minus r. So this is a probability density function for binomial distribution. So I'll use this to generate the graph. So I don't need anything again. So now let's get started. Now the first thing is n combination r. If you go to your calculator now, if you check your calculator, you have that function there, combination and permutation. Okay. So now, and the first thing now is to go to, I'm going to generate n combination r based on r and n. Okay, so therefore I have to use equals to, because it's a function. So I want n combination r. Okay, so now how do we do that, guys? Let me just tell you what combination is all about before I do that. So I just need to be clear. So n combination r is giving us, the formula is n factorial divided by n minus r factorial. If I were to end it like this, that would be permutation, then r factorial. So this combination now, such that permutation is combination is permutation over r factorial. Don't mind me, so n permutation over r factorial, something like that. But we are not doing so. That's what I want to do there now. So meaning that I need factorial function. So just write fact, and you see it is there. It's a function. So open a bracket now. So I now need to put what? N factorial. This is my n here. So this one, n factorial. Now guys, there's what we call absolute and relative reference. Absolute reference and relative reference. I don't want this a to change because I want to make use of it. So I'm going to, this will be absolute reference. Now your keyboard, you see F4. So you just press F and F4. It's going to add $sign at the back. So meaning that it's going to fix it. So that's absolute reference. So it's going to, that this, I reference this 8 and it's absolute. It's not relative. Okay, so I can close this now. So that is n factorial, because this is my n. My n is 8. So n factorial, okay? Then divided by, that's forward slash. You use forward slash for division. Divided by n minus r. This is still my n. N minus r factorial. So I still need factorial. Fact. Okay, so this n again. And it's still absolute reference, guys. So Fn F4. So to do absolute reference, or you can just add your $sign if it's not working for you. So then minus r. So here is my, this is my r here. So my r here is 0 for this one. Now this r here now, because I want it to vary, I can go to n combination 0, that is 8 combination 0, 8 combination 1, 8 combination 2, 8 combination 3. So it's relative, so it changes. So I don't need to make it, I don't need to do absolute reference here. So that's that. So I can close it. Then times r factorial. So times is your asterisk on your keyboard, and for some reason I can't even find, that's 8, shift 8. Okay, so times r factorial. So just press your fact again, just double click it, then r factorial. And the r factorial is also is a relative reference, it's not absolute reference. So just click it again and close it. Okay, so this factorial close this function for d6. Then this one is okay, but this fact here is for all, so you have to close this bracket once more. Now if I should hit enter key now, then it should generate n combination, that is 8 combination 0, and 8 combination 0 should give me 1. Okay, so what happened there? Let me check, sorry. Guys, can you go away? Okay, now factorial divided by fact, and this absolute 10 times. So what's going on? I think I'm okay. Minus r d6 times. So what happened, guys? Microsoft find the error factorial. Okay. I need to put it in brackets. Sorry about that. This factorial here, because it's meant to be n factorial over. Okay, let me just show you what is going on here. I think I like this. I like what happened here. The formula is actually n factorial divided by n minus r, then r factorial. So if you want to write this in coding, you have to put everything here in brackets, because it's n factorial everything over, is everything over. So n factorial will divide everything under. Okay, so that's what is going on there. Okay, so I understand. So now I need to place this in brackets now. Okay guys, thank you. Yeah, thank you, it's okay. So there should be bracket here, because this one here, there should be bracket at the front of this factorial. This factorial is for everything, so open the bracket here. So this one, close this, then this is okay now. So if I should click enter key, it should give me my answer 1. Okay, now you can now try 8 combination 1 should give me 8, 8 combination 2 should give me 28, like that. So if I should click this and drag down, then I should get the remaining answers. Yes, 828. You can just go ahead and use your calculator to confirm that, because of our time. Okay, next I want to do p r q n minus r, that is p raised to power, then my p here, this is p. Okay, so don't forget, that's what I want to do now. And if you look at my p there, this is my p here, and it's going to be absolute reference because I want to fix it, this one here. So to fix it, absolute reference, just press Fn F4 or just F4, it depends on the type of your PC, guys. Okay, or you can just go ahead and just put $sign at the back of B, and that and also depend on the cell you are using. Okay, so now P, then raised to power, because the formula here is P raised to power R, and this is my R here. So P raised to power, what do you use raised to power? Raised to power is just press shift 6, so you see this sign on your keyboard. So raised to power R, and this is my R here. Now this R, now my R is relative because it could be 1, 0, 1, 2, 3. So I need not to do absolute reference, so it's relative reference. So I'll leave it like that. So I'm done with that. Then so PR, then times Q2 now. So times, that is shift and 8. So it will give you that times. Okay. Q, what is my Q? 0.05. Q. But my Q should be fixed. So since it's fixed now, so that's absolute reference. So shift F4. Okay. Then the Q is raised to power n minus r. Now if you look at this n minus r here, is like a compound, n minus r all together. So in that case, I should open a bracket and put everything. So raised to power, don't forget raised to power function, just press shift 6. Then open a bracket now, because I want to put n minus r together. Okay, so this is my n. Okay, but my n minus r, it is, the n is fixed, so you have to press Fn F4 again because absolute reference. Okay, then minus r, this r is relative because it's changing from 0, 1, 2, 3, 4, 5, 6, 7, 8, so you don't need to put there. Then close the bracket here. Okay, I think everything is cool now, guys. Let's just click enter key, and the first answer there, I don't know if I should go ahead and just do that. Okay, now this gave me 3.90 raised power, so I don't want to use this. It's okay, it's correct, but let's go ahead and vary this one now. Let my success be 50-50. So let my success be 0.5, so that I can work with a small value, 0.5, and click enter key. Yeah, good. So I have, so you'll be able to use your calculator now. So that gave me 0.03. So go ahead and just go ahead and press P. That is 0.5 raised power 0. Okay. Then Q 0.5 raised power n minus 5. That is 8 minus 0. So that raised power 8. So you get this answer in your calculator. On your calculator, guys. So and now if I should drag down now, then it should automatically generate the remaining. So it should, when r change to 1 and when r change to 2, then it should generate the remaining formula, guys. And that's what we have there. GP is working. Okay, that's a cool one. Okay, finally, to get my probability density function for binomial distribution, that is n combination r, and this r I need to make it subscript. Sorry about that. Let me just quickly do that. format and subscript. Okay, so the complete probability density function for binomial distribution is n combination rp rkn minus r, and that's what I want to generate now. So to generate that, I'll just do this one times this. I'll just do n combination r times p rkn minus r. So what you just do now, press equal sign, then take this one, then times shift 8, that's times this. Game over, then press enter key, then it generates that. Right. And then I think I can just do something now. I want to just do this and double click so that you can have more. Okay, okay, it's going to fix exactly. I don't want to fix exactly. Control Z, guy. I think I like it like this. Okay, it's like I'm doing this guy at ICT class 0417. Okay, so just go ahead and drag down and you automate the remaining distribution model. Okay, now for some reason I just want to be sure that what I'm doing is correct. Let me just go ahead and see if I can extend this one. Okay, so I think it's cool. 0.039065. Yeah, it's okay. 0.5018. Okay, that's cool. So go ahead and just confirm with your calculator, guys. N combination R, that is 8 combination 1, 8 combination 2, 8 combination 3, and you get all this right. So guys, I'm through with my probability distribution model. The next thing is how to use this probability density function for binomial distribution to simulate the binomial distribution graph. Okay, to do that, I'm here already. What we just do is go to insert. For now, guys, I think it's not a bad one. Let it just keep on like that. So click insert, then go to column, then take this first one. But this is not the chart I want, okay, because I want to do axis label etc like that title. So just click here as 1 2 3 4 5. This is number 5. Okay, so take layout 5. So see, layout 5 automatically give you chart title and axis. So let me just quickly go ahead and edit my chart title. So what is the title for this graph? So this binomial distribution graph, binomial distribution graph. Okay, and just a minute, I just want to change that guys. Okay, or better still, let me just go ahead and pause. I just need to quickly do something quickly. Sorry about that, please. Let me just pause. Okay, guys, I'm sorry about that. I just need to change that track. Okay, now so binomial distribution graph. Then I want to edit my axis title too. So just backspace. So that should be probability distribution. Okay, so probability and distribution graph. Okay, probability distribution. Okay, let me just take a probability distribution. Let's say we have a random variable x and it's binomially distributed. Okay, so let's say x has a binomial distribution of something like that. That's how we write it in statistics. So just random variable x. So I will use TIDA there. TIDA is just spreadsheet very close to escape. So as a binomial distribution, bi. That's how we write it. Okay, guys. Just close this. Or bi. I don't know. Should I ask bi? Yeah, it's okay. Or let me just put it like this. That is, the random variable actually has a binomial distribution x. So something like that. I think it's okay like that. Okay, next, I want to be able to label this one, and because this is a random variable, I can change it from series. So in that case, just go to layout. And layout now, I can also put it in grid. I can do data label. Okay, you can see legend. and you can see axis title, you can see chart title. So let me go for axis title first. I want horizontal below, so you can go ahead and label this now. So I'm going to, that's the random variable, or it's actually probability density function, right? Yeah, these are the probability density function, right? I'm correct. 0.03 na, yeah. So probability density function, probability density function values. Let me just see values. Okay, I don't know why I put this one in uppercase and lowercase, guys. So density value, I can put uppercase, guys. So then what else? I think everything is cool now. We can just test run. Then also I want to label the data. So let me just go ahead and label the graph rather. I want to see what each stands for. So go back to your layout, and actually I want to add grid. Let me just add grid. Primary grid, major grid, and minor. Yeah, that's a good one. Then I want legend. Do I need legend? Okay, I don't need that. Let me just go to data label. Let me show data label with legend key. Okay, so let's do that again. Data label, data label. I think I saw something like data label. Okay, for some reason I don't know. Yeah, it's there already. So guys, I'm sorry about that. It's there. I clicked that before. So now, so let me just leave this back now. Okay, everything is okay now. So you can see that for when r is 1, the value you have there is 0.03, this one. So I try to label each one, and I can make this graph a little bit bigger so that you enjoy it, because that's the simulation, it's automation. So if you don't mind, you can just call this one unsupervised machine learning. So that's how powerful Excel can be. Now you can, if you don't mind, you can change your color. You can style your style, the style you want to use. So we have different style here. You can just choose, you can play with it, guys. I think I care little about that. Yo, whoa! I think I like that. Then this series, you can rename it too if you don't mind, but I don't have time. I've spent a lot of time, guys. You can just go ahead and play with Excel. Now let's see how it works. Let's see how it works now. Now the only thing is that I'm not going to write much here again. So I'm going to upload this on my test shop and my YouTube. Then you go ahead and do whatever you want to do there. Now let me teach you how it works now. Now you can vary the value of P of success to generate new Q, the failure. Okay, so then you generate probability density function, this one here. Okay, then automatically it's going to automate the graph. So for example now, let's say that the COVID vaccine produced by, I don't know whether it's biotech, Germany and America. I just love those two countries. Okay, so they are helping us. Okay, let's say that since that say it's 95% effective, and Russia says it's only 97% effective. Well, Nigeria, we are trying, but I'm trying to create the model, guys. Even though we cannot create that, guys. I think Nigeria is doing something. Sorry. Okay, so we are doing something too. Okay, so now let's go for 0.95. That is 95% effective. So just click enter. That will be 0.05. That's 5% failure. Okay, so yeah, you see the graph now. Okay, so that's a good one. So probably we're going to be like by next year, then everybody should be able to resume back. No more virtual learning, guys, but I doubt. Okay, so now let's say that, okay, maybe Nigeria want to, why am I using Nigeria? I don't want to be. Okay, let me say a country that does not exist want to try to produce similar vaccine, COVID vaccine, and it's not working at all because probably they don't know how to go about it. So let's say that you have 10% of success there. So 10% will mean let's give them a little, let's say 30%. So 30% will be 0.3. So if success is 0.3, and then failure will be 70%. And let's see what will happen to the graph. Just click enter key. Yeah, guys, so that's how it works. So for now, guys, I need to show you something now. Let me quickly pause now and show you something, guys. Okay, guys, I just want to show you something now. So make sure you do well to subscribe to my channel, and just go ahead and click subscribe. And I'm going to make the script that is I will take a like a form of, there's a way you can actually check the code if you don't want to watch the video also. You can just check it. If you click on here, you see all the codes how to go ahead and create the the binomial distribution simulation model graph. Okay, so I'll make this available. Okay guys, to check the formula used for this, you just press Ctrl Tilde. Tilde is toward the left hand side, immediately before one of your keyboard. Ctrl Tilde. So just press Ctrl Tilde, then it will show you the formula that generates that. So don't forget, I'm going to upload this via on my test shop. So just go ahead and download all the formulas to do this, and you can access as many video and resources as possible. And I have a lot of videos also for you to work with, guys. Go ahead and enjoy yourself, and do have a great day ahead. So let's end with this note, guys. Let's just end with this note. Do have a great day ahead. Bye, guys. Let's end with this note.
Break the streets up.